welcome back to Iron Archery Outdoors. So I see a lot of talk, it's been around forever, of different arrow components. So I made kind of like a little mock-up dummy thing here. And you're probably wondering why. And why do I have a vise and a hammer? Because I'm going to test these two. And I'm going to show you what happens. Okay. There's two systems that are very popular across the board where usually most times you go to an archery shoot or a tack event, especially when you're finding a lot of arrows. Two systems you're going to find the most. One is you have a half-out system, okay, where you have a portion sticking out and the rest of the insert on the inside. Okay, they look like this. So this is a half-out insert. Okay, this is an Easton 75 grain stainless half-out. Okay, so there's some glue on there. I've used these before. But that is a half-out. Now, this system is a hit insert and collar system. So what a hit insert is, looks just like this. So this is a hit insert. This insert right here has threads on one side and nothing on this side. Some of them do have threads on here where you can add additional weights on. This one, no. This is a 25 grain Easton aluminum hit insert, which is what I have inside of this side with the collar. This is a 10 grain titanium iron will collar, which just slides over the end of the shaft. Okay. The reason I'm showing this is because I actually had an incident at a local bow shop like 2 weeks ago, where I literally went there. I was just going to shoot some 5-spot with a buddy, and I was like, well, I'm already sighted in for my hunting arrows, I'm just going to use them anyway, which were a 515 grain Rip TKO 250 spine, and I shot 4 arrows, and my 5th arrow, my D-loop broke. I knew it was frayed a little bit, but I didn't think it was quite that bad, and I'm kind of glad it happened then, and not drawing back on a big buck. Well, so what happened is in the roof, or the ceiling of this archery shop, there's big steel beams, okay, that are open. And well, when the loop broke, this arrow hit the beam. This is coming off of an 80-pound Hoyt AX229 at a 28.25 inch draw length. With a 515 grain arrow, it's around 280 to 285 feet per second. That's sub 90 foot-pounds energy, somewhere right in there, 88, 90 foot-pounds energy. So, I mean, it's packing some punch. And this beam was literally about 10 yards away when it broke. And this is what the front of my arrow looked like. Okay. Bent the living heck out of that thing. I was surprised that it even actually unscrewed. Okay. The aluminum hit insert is the one that's in here now. Was not the insert that was in there at the time. I had a 75 grain brass insert in here then before, which is still good. I threw it back in my tray. But anyway, so it's a little more durable than what this is right now. But so you can pretty much see how bad that tip is. But this is the section of arrow that this was fronted to. It snapped my arrow back here. I just cut it off a little bit, flushed it out, squared off the end, and glued a half out in here so we can do this test. So you can barely see just the tip of the edge of that collar, just barely rolled. It's hard to see it. Right there, right on the top. Barely rolled it. Maybe if I put a field tip on, you'll be able to see it a little easier. Maybe. You can kind of see it a little there. Right there. So right on the top, there's a little divot. Is where the edge of this collar essentially got slammed over. So you can barely tell. I mean, it's technically still shootable. But, so half-outs are very, very popular. I mean, they're super easy system. You just glue it and slide it in. You're done. Hit insert, you gotta slide your hit insert in there, put your collar over, and I usually hot melt my collars on. But so many people are like, well, I don't like systems that slide over my shaft or what, for whatever reason. If you're shooting a bag target, I understand because they pull out like crap out of a bag target, but that's fine because I absolutely hate bag targets to begin with. But half-out systems is, I've gotten a few different disputes of people that really hated other systems and they swore on half-out system. And I'm like, why? Like, why do you like the half-out system so much? Because they're prone to bending. The reason is there's nothing protecting the top of the shaft at all. Okay, just the structural integrity of that joint right there to my fingernail. That's it. Okay, there's nothing preventing. Once this bends, 99% of the time it's cracking the end of that arrow. Okay, and usually if you're gonna mess up a hit and collar system, your arrow's junk anyway. Completely junk. So what we're gonna do is a little test. So I drew a silver line. The silver line is 1 inch from the base of the field tip on both ends down the shaft. It's just kind of a control mark. So, whatever. That's where I'm going to set the edge of the vise. And in theory, this one will probably be a slight disadvantage. Well, they're probably about the same, actually, as far as material that's inside the shaft. I'm going to try to do as equal hits as I can, like force-wise, but we're going to find out. So, let's try to zoom this in a little bit. Of course, it doesn't let me zoom in. That's nice. So let's have to see what happens. Okay, so I barely hit that, and look what I did. So we're going to take this out. I already started to break the shaft. So you can imagine that hitting something. I don't think I'm able to get this out. Because they're glued in with a max impact glue. I really do like this stuff. It's been really good. So I want to see if it bent the insert. Actually, that didn't take much at all. That actually broke the insert. Right at the base of the field tip. That's what happens with a half-out. Okay? That is why I do not shoot them anymore. That was 2 hits, barely at all. Okay? So now you take that example, and you put a broader in the front of that, and say you're shooting at a quarter and shoulder blade, right? So you're like this. Coming in like this at an angle, you think this is just going to perfectly puncture through? No, it is going to take side pressure, like this. You're hitting it at an angle, like this. Which means a lot of that force is going to go that way, right? And it's going to bend that tip. A lot of times it's going to bend it. If you catch something hard, it is going to bend it, and it's going to break, just like that one did. So now, we're going to do the hit system with a collar. It might bend because of the aluminum insert, which I don't use aluminum inserts in these in a hunting scenario. I run a 75 grain titanium hit insert, which is a lot longer, so it's far more durable than this. But so we got a similar ending, but what you're going to see, actually, is I don't think it. Okay. So it broke the hit insert, there, back here. Okay. So that is simply a weakened insert, essentially. Okay. So obviously you've seen it took more hits before it actually started to do anything. But what you're seeing is you're taking all that flex back here to break that arrow off, rather than the end of the arrow splintering with direct side force, okay? Which obviously you're not getting that result in the field, okay? Now, I would do this with a titanium hit insert, but I just don't want to mess them up because they're not cheap. And I'm not sponsored by nobody, but I'm going to show you one, if I have one open. I'm not sure if I do. I don't. I do not have a titanium one open. These are all stainless ones. Dang. But I can show you a stainless one. Thought I had a titanium one out here, but a titanium versus aluminum, or a stainless. So here's what we had in there, in the arrow, and that's a stainless one. Quite a bit longer. That's a 75 grain stainless, and this is a 25 grain aluminum. So it's longer, quite a bit longer. And I'll tell you what, if I was to use this similar component inside behind the hit, behind the hit and collar system, this would not have broke as easy. It would have took a lot more abuse. Okay. So another reason I hate aluminum inserts. Mind you, these are a cheap aluminum. You know, they're probably a 60-61 or a 60-65 aluminum. So if you use like a 70-75 aluminum, definitely be better. But or brass, definitely better than aluminum. But what it's going to show is how little impact that took to break that half-out. And that was a stainless half-out. Okay? And that broke pretty high. I mean, that only broke 3/16 from the base of that insert. Pretty weak. Pretty weak. And this is a 250 spine rip TKO shaft. So, garbage. So you can take that for whatever you take it as. I mean, did it really prove a whole bunch of durability? Not really, because it still broke. But that's based on the aluminum component inside. So this one was technically already at a disadvantage. And it definitely took more hits. And I probably hit that a little bit harder too. But now you put a titanium hit insert behind that. You know, that titanium hit insert is probably that far into that shaft. I mean, you're looking at over 2 inches inside that shaft. That is a ton of durability inside that arrow shaft. And that's the system I hunt with. And I'll tell you one thing, I have not bent one yet. No, I have not. Not even close. It will break the arrow somewhere in the middle of the arrow before it does anything to the front of that arrow. And that's usually, if I have something happen, it's usually due to A, shooting through an animal, and it deflecting really hard off of something, like catching the side, like literally catching the side of the tree, just launching that arrow. I've had them break that way. Or if I hit something really hard directly, like a steel target, I've had shafts break that way. And that was several inches behind the hit insert. So it has nothing to do with the front component, which it did absolutely nothing to the front end of the arrow. And that is the point I'm getting at. Because if you are at a slight deflection, mind you, let's take a lower poundage bow. This one here. This is a Bowtech Eva Gen 3 at a 25-inch draw at 42 pounds. This bow is like 36, 37 foot-pounds of energy, okay? So if you take a very low poundage energy, any little deviation in that impact, so if you hit a little bit of an angle, and all of a sudden that half out bends a little bit, where do you think your kinetic energy is going? It ain't going forward anymore. It is literally devastating. Probably 90% of that kinetic energy putting out that's hitting that thing. Okay, so as soon as that hit insert or that half out bends, all that force that's behind that arrow is going into bending that hit insert or that half out insert even more and probably breaking it. Mind you, 30 some pounds energy, you're probably not going to break one. But now you put that behind something that's 80, 90 foot-pounds of energy, your chances of bending that half out are drastically higher. I've done it numerous times. Even at normal 3D shoots, I just glance one, rips through a target, bounces off a tree, arrow doesn't go very far, or just catches a tree at a funny angle and just kind of kicks over. Bends. Why? Okay? There's a lot of pros and cons to either one. Yes, one system is cheaper than the other one, but in the end of it, one bends, crushes your arrow. The other one, your chances of it bending aren't going to happen. If you're going to hit something hard enough, it's got to break the shaft first. So, hope it kind of helps you make a little decision on something. If you're going to the woods, make sure you got a component that's strong.